Alright, unlike some of the other videos we've done, this video is purely review. You should have already done these problems, and so I'm just going to work through them with you. When I write the number of the problem, I'm just going to do that problem. I might do one on a page, I might do more than one on a page, but this is entirely for you to be able to check your work as you are working, since I am not there. Alright, let's work through the first section here. These are all proportions, so these are all from 7-1. And let's work through each of these one at a time. Number 1 says 2 over x is equal, 2 over 5, I'm sorry, is equal to x over 25. Remember, the way to solve here is to create a cross product. And once you've created a cross product, then you should be able to solve that cross product for x the same way that you would any other equation for x. In this case, I'm going to divide both sides by 5. Okay, so if I divide 25 by 5, it ends up being 5. So x will end up being 5 times 2, or 10. Let's look at number 2. Number 2 says 10 over 3 equals 7 over x. 7 over x, same type of problem, same type of methodology. 10x equals 7 times 3. Divide both sides by 10. So that does leave you with 21 over 10, or 2.1. So for those of you that were concerned that your answer couldn't be correct because it's a decimal, you were still right. The answer was in fact a decimal. And that's okay. Sometimes it is. Number 3. This one gets a little bit more complicated, but I have confidence that you guys can do this using the distributive property. Let's look at this. Y plus 4 over 11 equals y minus 2 over 9. Again, with your cross product. But this time it does involve the distributive property. Let's multiply this way. 9 times y plus 4 equals 11 times y minus 2. Go ahead and distribute your 9. So you end up with 9y plus 36 equals 11y minus 22. Subtract, let's do it the other way. Subtract 9y from both sides and add 22 to both sides. Okay, I'm going to move over here because I'm running out of space. So I'm going to end up with 2y equals 58 and y equals 29. All right, number 4. Same type of problem as number 3, except this does require you to remember a little bit of algebra. Okay, z minus 1 over 3 equals 8 over z plus 1. Remember, we're still going to use the cross product, but remember what happens when we have an a plus b times a minus b situation, right? In case you don't remember, let me give you a hint. A plus b times a minus b always equals a squared minus b squared, right? So here's my a term, here's my b term. So I'm going to end up with a squared, which is z squared, minus b squared, which is 1 squared. Okay? So I'm going to do that cross product here for you. Z squared minus 1 equals 8 times 3. It's 24, so z squared equals 25. Z equals plus or minus 5 when you take the square root of both sides. Look at number 5. It's a story problem. So before you get scared off by all the words, look at what you need to know. A pitcher's earned run average, or ERA, is the product of 9 and the ratio of runs the pitcher has allowed to the number of innings pitched. So you already have some information that's really important here, right? ERA is equal to 9 times runs over innings. So now you know what kind of information you need to look for. You can ignore everything else as you go through that problem. During the 2000 season, Johan Santana, of the Minnesota Twins allowed 81 earned runs in 219 innings pitched. So we're told that he has 81 runs, and he has pitched, I think it said 219 innings. Yeah, 219 innings. Right? So here's my proportion, or my ratio. Set up this way. Okay. So if you want to estimate to a decimal, let's get a calculator. Move it over here so you can see what we're doing. Alright, I'm going to take 9, and I'm going to multiply it times 81 over 219. Now you noticed, I'm sure, that I put parentheses in there. Why would I do that? I'm putting parentheses in there because if I don't put parentheses in there, okay, the calculator will multiply first, right? So, and I wanted to do what I wanted to do. Rather than having it mix up the order. Now, because multiplication is commutative, in this particular case, it doesn't matter a whole lot, but I like to do it that way anyway. Okay, so we're looking at 9 times whatever that decimal was. We can go back and look at it, I think. No, maybe not. Okay, so we end up with 9 times whatever this decimal is, and the answer ends up being, let me pull that calculator back up for you, 3.328. We're going to round to the nearest hundredth. So 3.328 actually ends up being 3.33. Okay? Number 6. Let's look at number 6 now. We are told for number 6 and number 7 that each of the polygons is similar. Okay, each of the polygons is similar. So I'm not actually going to draw the shapes. The book does a really nice job of drawing the shapes. I'm just going to do a terrible job drawing the shapes. But you have the shapes in front of you. You can see that the sides are corresponding here. If you're told that each of the sides are corresponding, are similar, because you're told that the polygons are similar, then you can set up a proportion, right? You can set up this proportion. BC over AC is equal to QR over PR. Now I have enough values here that I can figure out the missing value. The missing value is X, so I can fill in the blanks for all of the other things that I have, right? 8 over 10 equals, let's see, QR is 18 over X, okay? So if I do my same cross product, 8, whoops, let's not do that. Go back to my black pen here. 8x equals 180. So then x is actually equal to 22.5. Alright? Again, the same idea, just recognizing that the different pieces are corresponding. I would recommend that you actually go ahead and write down which pieces are corresponding before you actually do this problem. Right, because in the next problem you can see in the trapezoid that you're going to have to flip the thing over, okay? Because you've got to put the corresponding angles that are congruent in the same position. So if you look at angle Z and angle F, those are the ones. So you're either going to have to reflect the big one or reflect the little one to get the correct proportion, okay? So, but it's still more or less the same thing, right? 4x plus 3 is proportional to x plus 9, okay, while 20 is proportional to 15. Now, I'm looking at the book, and I'm looking at that figure, and I'm getting a little bit concerned. And the reason I'm getting a little bit concerned
is because once I reflect that over, those sides don't correspond anymore. And so if you look in the book and check your answer, you're going to find the answer that I'm about to calculate for you here. I believe that there's a mistake in the textbook here. I believe that angles S and F are supposed to correspond, because without knowing that the thing is an isosceles trapezoid, it is impossible for us to figure out this particular proportion correctly. So we're going to make that assumption and do it this way. Go ahead and distribute your values. And you're going to end up with these values. 40x is going to end up equaling 135. So you do get an x value that's 3.4. Okay? And so in order for that to work, they should have drawn the other two congruent, other two angles corresponding rather than the ones that they did. But this is the way to set this one up. All right, let's look at number 8. Two similar polygons have a scale factor of 3 to 5. So you're told that the scale factor is 3 to 5. Okay? And then you're told that the perimeter of one is 100 and I believe it's 120 feet. It says find the perimeter of the smaller polygon, right? So this is the big one. Okay, so for my proportion of 3 to 5, the one that's got the proportion of 5 is 120. I'm going to call this P for polygon. So I've got this 120 times 3 divided by 5. Okay, and that gives me 24 times 3, or 72, right? So if I reduce this here, and divide this by 5, I get 24. So this is 72. Number 9. Number 9 says determine whether the triangles are similar and write a similarity statement. And if they're not similar, go ahead and prove, tell me what you would need to prove that they are similar, explaining your reasoning. So if you look at the triangle number 9, you can see that QR and XY are parallel. So remember what we learned from the previous postulates earlier in this chapter. We can figure out that there are certain angles then in that figure that will be congruent, right? Let's see if I can do it anyway. You have to imagine it kind of laid up on its side. See if I can turn it. Maybe, maybe not. All right, so if I have this triangle and I want to draw a line, and I want to make it parallel to the bottom. Okay, and I tell you that these two lines are parallel. I tell you that these two lines are in fact parallel. Okay, then I know something about these angles, right? I know that if these two lines are parallel, I know that these angles are congruent because of the corresponding angles theorem that we learned way, way, way early on. And if that's true, right, we also know then that the sides are proportional. And so because of this, though, we now have also angle-angle similarity. Remember, you only need two congruent angles for two polygons to be similar, right? So we can write the similarity statement. Okay, triangle X, Y, Z is similar to triangle QRZ. Remember, the order of your letters is important. Number 10. Same idea. You're given two triangles. Okay, now one thing I want you to notice is that the missing angle, okay, the missing angle, they can't be congruent, right? Because I have a 48 and, a 49 and a 53, and even though the 61s are congruent, the 49 and the 53 are not. And so because of that, these triangles cannot be similar. So how would you write that? You would say no. There are not
two congruent angles. So the triangles cannot be similar, right? It is not anything that you need to overcomplicate. Just the triangles don't have two angles that are congruent. They don't give you any information about sides, okay? Again, in numbers 11 and 12, we'll be doing something similar, okay? Except you're going to be asked to find the missing measures. In number 11, you can see that there are two congruent angles, and so therefore, those triangles must be similar. If those triangles are similar, then you can flip and rotate RST, okay, to fit that 87 down in that corner there. And then what you can do is you can set up a proportion, right? 3 is proportional to 12. And X is proportional to 16. We're going to solve the same cross product, right? So if you guys are having trouble understanding cross products, that would be a good thing to come to me about soon. And I say that because obviously from looking at this, you can see that cross products are very, very important. And most of you guys are doing a very good job with them. 12. You want to find the length of AF. Again, you're given the proportions, right? You are going to have to do a sum here. So you know from looking at this triangle that AC is proportional to AD. Which means that also AB is proportional to AF. I do have number values for these, right? I know that AC is 15 because I can add 9 and 6. And I know that AD is 9. I know that the whole of AB is 18. And AF is X. End up with 15X. 9 times 18. Oh my goodness. 9 times 18 is 171. All right, so you are going to get a decimal. Okay, you are going to get a decimal when you divide this. That can't be right. It's not 171. My arithmetic was incorrect. It's what happens when I try to do it in my head. It's 162. My apologies. It's actually 162. Okay. Yeah. So you are still going to get a decimal, okay, and it's going to end up being 10.8. All right. 13. 13 is kind of a cool thing. This is actually how fonts are developed, and this is how we as people find certain fonts more pleasing than others. And so you're told information about the square, and the thickness of the major stroke is 1/12 the height of the letter. So you're told that the thickness of the major stroke is equal to 1/12 the height of the letter, right? And so the first part tells you, let's put an H for height here. The first part tells you to explain why the bar through the middle is half the length of the space between the outside bottom corners of the sides of the letter. Okay, this is because if you look at that picture, that bar connects the midpoints of those two sides. Okay, when it connects the midpoints, remember we learned from the midsegment theorem that that must mean that the midsegment is parallel. So if the midsegment is parallel, then the measurement of that is 1/2 of the base equals the length of the midsegment. Right? And so we know that it's 1/2. Okay? The second part asks us to calculate
If the letter were 3 centimeters tall, how wide would the major stroke be? So we're looking at h equals 3. So we know that it's 1/12 of that. 1/12 times 3 is equal to 3 over 12 is equal to 1/4. You can also give it, I think the book gives it as 0.25, same value, 14. 14, okay, gives me two sets of parallel lines. Remember what we learned, that if there's two sets of parallel lines and they're cut off at congruent portions, then the other parts must also be congruent. They want you to find x and y. So we have two equations to fill here. 3x minus 9 equals 4x plus 22, I believe. 4x minus 22. I don't know why I wrote it that way. And then once we solve that one, we also have the other portion, which is 17 plus 5y equals 13 plus 6y. So here we go, let's subtract 3x from both sides and add 22 to both sides, in which case we end up with x equals 13. That worked out nice. Subtract 5y from both sides and subtract 13 from both sides. You end up with y equals 4. Okay. Last one, coming down the home stretch here. Number 15. Same thing with the triangles, right? It tells you that those corresponding angles are congruent, which tells you that those sides are parallel, which tells you that the mid-segment and the base are parallel, which then leads us to our same rules about parallel lines and transversals. Okay, so we're going to go ahead and set those equal to each other as well. 12 minus 2x equals 8x minus 18. 7y equals 5y plus 16. Okay, so what I'm looking here is 10x equals 30. X equals 3. And down here I've got 2y equals 16. Y equals 8. Alright, hopefully these were helpful. I know I didn't draw the pictures. It's very hard to draw the pictures on this. One day I will figure out how to do that. And as you go along and you are checking your answers, please make sure to feel free to go ahead and check, right, against both what I'm doing and in the book. Good luck. Hopefully you guys do a great job. I will see you guys on Wednesday.